In this problem, AP92 number 1, you have an object that's dropped from a certain height above the ground, known mass and known height. It falls, it hits the ground, and there's a completely elastic collision. But at the same time that it hits the ground, the exact same instant it hits the ground, a second ball, I'll make it a darker one here, a second ball is released and falls downward. So what the situation is, you have an object moving up, and it's going to decelerate, and an object moving down is going to accelerate due to gravity. And at some point in the middle, I'll just pick a point, at some point in the middle there's going to be a collision. So what they need you to find is a couple things. What the speed of the ball, of the hollow ball, is before it hits the ground. So that's a kinematic type problem. Then we get something a little more interesting here. At the instant you leave this and let this darker ball fall, they want you to find the time it takes for there to be the collision, what this elapsed time is. They want you to find how high above the ground this is. I'll call it h. Again, remember, you do know this distance here. This distance from the top to the bottom, this is the distance h. That's a known value. I think it's 5 meters. And then they want you to find the velocities before and after the collision. So the collision sounds like there's conservation of momentum there, or something like that. So the way they approach the problem is the following. This is an object that starts from a known velocity, and you know that from the previous part because it's an elastic collision, and it slows down or decelerates due to gravity. Here's an object at the very top that starts from rest, and it accelerates. So you basically have two objects that are accelerating and decelerating and approaching one another. We do know that the total distance traveled between the two of them is capital H. So if you think of this as two objects approaching one another, like two cars approaching one another like this, maybe the darker one, you know this total distance here, you want to find out where they meet in the middle. So to find the t for the time and the h, or the distance traveled, that's a kinematic type problem. For the velocities before the collision, that's also part of a kinematic type problem. But the velocities after the collision, so there's a collision, so there's conservation of momentum that occurs there. However, just to clarify one thing, most people would say, well, wait a second. For conservation of momentum to apply, there has to be no net external force. However, gravity is still acting on both objects. So what we say is that because the collision happens at an instant, a very infinitesimally small amount of time, gravity doesn't have the time yet to work on them to change their velocity. So if this were a lengthy collision that occurred over a second or two, then yeah, gravity would act on them and then conservation of momentum wouldn't apply. But because most collisions happen in a fraction of a second, tenth of a second, hundredths of a second, thousandths of a second, gravity doesn't have any time really to act on the objects and change their velocities and therefore violate conservation of momentum. So those are the hints for AP problem 92-1.